Today we enter the second learning standard of this topic. You need to know how to compare and contrast directed graphs and undirected graphs, and also weighted graphs and unweighted graphs. So we look at directed graph. What is directed graph? Direct, it means that you have direction. So direction is assigned. Look at the diagram, you can see that there is a directions. Okay, 3 direction is assigned. So this is a directed graph. Represent the flow of the certain process. So you can see that there is a process. Examples: the road maps, the airlines network, electrical circuits, and the computer network. This is a simple directed graph. So the edge AB, A is the initial vertex and B is the terminal vertex. You can look at the arrow, the directions. And the edge CB, so C is the initial vertex and B is the terminal vertex. So therefore it's named as C to B. And all vertices are connected in one direction only. Then, what is this graph? This is a directed graph because there is a direction assigned. So directed graph with a loop. So you can see there is a loop at vertex Q and the multiple edges at vertex P and R. So this is a graph, directed graph with a loop and multiple edges. We look at E4. E4 that link vertex P to R. So P will be the initial vertex and R will be the terminal vertex. So it's from P to R. We look at E5. E5 is the pair of vertex RP, not PR. It's RP because R is the initial vertex and P is the terminal vertex. Then we go to E2. E2 is a loop, therefore the edge is written as QQ. Okay, so it means that Q is the initial vertex and the terminal vertex is both because E2 is a loop. Just now it's a directed graph and now it's an undirected graph. So what is an undirected graph? It's very easy. So it's just a simple graph or a graph with loops and multiple edges drawn without any direction being assigned. So undirected graph got no directions be assigned. So it's the graph that you learned previously, okay, with no directions. So it is an undirected graph. The simple graph can be divided into 2 types, undirected graph and the directed graph. So directed graph you have learned just now. And you can see that we focus on the edges, okay? The edge here, the order of the vertices written is not important. And both pair of vertices AB, BA represent the edge of AB. So it means that the edge of AB, you can write BA also, not necessarily AB. The order is not important. Now we go to directed graph. So the set of vertices also the same as the undirected graph, just the edge, the set of E is different. So you can see the directed graph, you got the directions, okay? And the order of the vertices are written according to the direction of the edge. For example, BA here, you cannot write as AB because the direction here points from B to A. It means that B is the initial vertex and A is the terminal vertex. So you should write BA. Then for CA, you should write CA because C is the initial vertex and A is the terminal vertex. You cannot write AC, and same as BC, where B is the initial, C is the terminal, and DC also, D is the initial and C is the terminal, so should be written orderly. Then we go to the degree. So let's see how it calculates. So degree in, and you got degree out for vertex A. So we look at A here. So A, degree in means number of edge going into vertex A. We look at vertex A. So in means number of edges going into. So you can see that 1, 2, 2 edges, okay, 2 edges going into vertex A, so it's 2. And degree D out means number of edges coming out from vertex A. So how many number of edges coming out from vertex A? See, like no edges coming out from vertex A, so it's 0. So for degree A, in plus out, so 2 plus 0 is 2. So same as the rest. So you can see that for vertex B, we go to another example. For vertex B, how many edges going into? So no edges going into, so it's 0. Then how many vertex going out? You can see that it's 2. It's 2. Then we go to C. How many vertex going in? So you can see that 1, 2 vertex going in into vertex C. 2 edges going into vertex C. And how many edges going out? So just edge going out, 1 edge going out. So you got 2, degree in is 2 and degree out is 1. Then how about D? How many edge going in? Nothing, so it's 0. It's 0. And how many going out? So just 1 edge is going out, so the degree out is 1. Then you plus all, 2 plus 2 plus 1 plus 1 plus 2, so the degree of this theoretic graph is 8. Now we go to graph with loops and multiple edges, also divided into 2 types, theoretic graph and untheoretic graph. So theoretic graph you have learned just now, all are the same, just the theoretic graph got a little bit different. So the set B are same as the untheoretic graph, PQRST, and the set E is different because there is a direction assigned here and you must follow the directions, and you have to identify where is the initial vertex and the terminal vertex. So I just explained the multiple and the loop, okay? So we go to the multiple edges. You got QR. You cannot write QR twice because there is a direction here. So QR, one is QR, one will be RQ because Q here is the, so for QR, Q is the initial and R will be the terminal. So if you write RQ, so R will be the initial and Q will be the terminal. Then we look at loop. The loop is also TT because the vertex T is the initial and also the terminal. Now we go to the degree. So for the degree here is same as the simple graph, directed graph, simple directed graph just now, okay? So one is in, degree in, another is degree out. So I just focus on the loop, okay? So for loop, degree in T, so how many vertex going in? So for a loop, T is an initial vertex and also a terminal vertex. So you can see that only got 1 edge going in the terminal, okay? Going in the T. 1 edge going in vertex T. So therefore the degree here will be 1. So therefore the degree here will be 1 because from here 1 in and 1 out. Then how many out? since the loop got 1 out and plus this 2 and 3, so therefore you got 3 the degree here, and then you edit all the degree, so came out with 14. Then we go to the weighted graph and unweighted graph. So what type of graph for weighted graph? So you can have a directed graph and undirected graph. You can have a weighted graph. So same as the unweighted graph, also happen in directed graph and undirected graph. So the edge for the weighted graph, it means a weight, so must be associated with a value. The edge, okay, the edge must associated with a value or a weight. For unweighted graph, unweighted, it means that no value is associated or no weight. For example, for the weighted graph, distance between two cities, how many kilograms you write at the edge, or traveling time. So how many minutes, how many hours you write at the edge or you label at the edge, or the current in an electrical circuit. How about the unweighted graph? For the unweighted graph, the edge relates information like just the flow method, the tree method, the simple method, okay, or the job hierarchy. When we look at the example with the diagram, this is a weighted graph. You can see that the edge, you got the distance here, okay. How about the unweighted graph? Nothing is labeled, just a simple. Let's see how to draw a directed graph based on the given information. So the information they given here is V. You have P, Q, R, S, T, U. So you have 6 vertices, and the edges you have 1, 2, 3, 4, 5, 6. 6 edges. So for these questions is to draw a directed graph. So first you can do is you list out the vertex pair and the directions. So you got 1, 2, 3, 4, 5, 6. 6 vertex pair since you have 6 edges, and these are all the directions because directed graph you have the directions. So for example, for the first vertex pair PQ, it means that the direction must be from P to Q. And we look at the third one, RQ, it means that the direction must be from R to Q. So you can see that 2 edges from vertex P, and then 3 edges will come up from vertex S, okay. So and T, only vertex T connected to the vertex S. So what you need to do is you have to draw the vertex. So 6 vertices, 1, 2, 3, 4, 5, 6, and then we label P, Q, R, S, T, U, and then we draw the edges. So first 2 means 2 edges from vertex P, so the 2 lines will come out from P. P join to Q, so another line is from P to R. And then R to Q, we just draw a line, they join vertex R and Q. Then we look at here, the vertex S. There are 3 edges from vertex S, therefore from vertex S we have to draw 3 lines. So first is S joined to R, second S to Q, and another one is S to T. So after that we need to draw the directions. So we came back to the first one, the direction P to Q. So we draw the arrow from P to Q. It means that P is the initial vertex and Q is the terminal. then P to R. The third one is R to Q. The fourth one is S to R. The fifth one is S to Q. And the sixth is S to T. Then you can see that the vertex U is alone. Okay, nothing edges that join vertex U, and it is known as isolated vertex. Example B. So now what directed graph we need to draw is, we look at this information. Now there is a loop at vertex Q, and RS is a multiple edge, so such that if you fulfill these informations. So first we need to draw the vertex. So how many vertices here we have? So you see that you got P, Q, R, S, so it means that you have 4 vertices. So you have to draw 4 dots, and then you label it P, Q, R, S. Then remember we have to draw the loop first and the multiple edge. So there's a loop at vertex Q, so we draw a loop. And then there is a RS, multiple edges at RS, so we draw the multiple edges. Then we are going to draw the rest of the edges. So what we have to do? We look at vertex P. You got degree in 1 and degree out 1. It means that overall you got 2 degree from at vertex P. It means that 2 degree means 2 edges that came out from P. So vertex Q, you got 3 plus 2, 5 degree. So 5 degree means you got 5 edges that came out from vertex Q. And then we go to R. R, you got degree 3. It means that you have 3 edges that came out from vertex R. And then we look at S. S, you have 3 plus 1, 4. You got degree 4. It means that you have 4 edges that came out from S. Then how will you draw the edges? We just draw a part first. So just now I told you that vertex P, you have 2 edges that came out from vertex P, so we draw 2 edges like this, just a part. Okay, and then we go to Q. Q, you have 5 edges, but just now you already draw a loop. So remember the loop represents degree 2. So 2 edges. Then 5 minus 2, you have 3. So therefore you draw another 3. 1, 2, 3. Then we go to R. So remember R, you have multiple edges. So 1 here, 1 edge here. So the edges here is 2. But vertex R, you got 3 edges came out from R. Therefore 3 minus 2, you draw another 1. And how about the vertex S? You already have the multiple edges here, 1, 1. So 4 here, you minus 2, 4 minus 1 minus 1, 4 minus 1 minus 1, so you left 2. You draw another 2 edges. So it seems that we can join all the parts of the edges, so we just join it. Okay, so we nearly finished. Remember, this is a directed graph, so we have to assign a directions. So how we assign directions? You can see here the degree in for vertex P. It means that 1 arrow must in and 1 arrow must out. Okay, degree out, so go out. Degree in, go in. Then we go to Q. Degree in is 3, degree out is 2. So a loop, we have 1 out, 1 in. So the loop here we got 1 in and 1 out. Then since you have 1 in, so we need another 2 in. So another 2 in means that 1 in here go to Q, another here also in go to Q. So 2 in, since another degree in already drawn just now. Then we look at degree out. So the loop go 1 degree out, so we draw another out like this. Then we go to vertex R. Vertex R degree in is nothing, 0. But degree out we got 3, so you already draw one out just now. So we draw another 2. 1, 2. So we have complete the graph. Example 4. So this diagram shows one-way path that Izaru can choose for his running practice. So vertex V1 is the starting point, starting positions, and V5 is the ending position before he goes home. Then part A, determine the shortest distance from V1 to V5. So you can see that, or you do the calculation which one is the shortest distance. So you can see that V1 to V2 and then to V5 will give you the shortest distance, that is 600 plus 500 and 1100 meters. And B, you find the longest distance from V1 to V5, and you can see that the longest distance is from V1 go to V2, and then V2 go to V3, V3 go to V4, V4 go to V5. And when you add all the distance, okay, when you add all the distance will give you 2500 meters, and where it is the longest one. Then you determine the vertices that must be passed through. If the distance of the one-way run is between 1.4 km and 2.1 km, then you need to do some calculations. You got two answers. So from V1 to V3 to V4 and then to V5 will give you 1.5 km, where it is between 1.4 and 2.1. Another one is you can go from V1, then V2, then V4, and then V5 will give you 1.9 km, where it is still between 1.4 km and 2.1 km. You can try some exercises. This is complete self-practice 5.1b, page 138, from question 1 to question 4.